All right, so now we're going to look at the end behavior of polynomials. So let's take a look at that. So here we go with end behavior of polynomials, and this is an add-on, of course, to what we talked about yesterday. So the idea that we talked about yesterday was specifically the leading coefficient. What the characteristics of what went on when the leading coefficient was positive or negative, and and what was going on with the degree. So the idea is that if we've got let's look at the leading coefficient first. So the leading coefficient, right? If the leading coefficient is positive, right, then what's going on is our function is increasing to the right, is rising right. Let's say it. It's rising to the right. Now, if our leading coefficient is negative, it is falling to the right. Okay, so that's the first thing we want to look at. The second thing we want to look at is we want to look at the degree. So the degree of the polynomial. So if the degree of the polynomial is even, right, then both sides are the same. Right, both ends are both, yeah, I should probably say both ends because we are talking about end behavior here, right? And if the degree is odd, then the ends are different. So this is the key thing we want to bear in mind looking at this, okay? So what is the end behavior of the graph of Q? Well, this is quite simple to see now, right? Because our leading coefficient here is negative, right? It's negative leading coefficient, so that means that it's going to fall to the right. Okay, so I'm going to just draw that in there. So it's negative coefficient, so it's falling to the right. And then we have an odd degree, which means that, well, the other side is going to rise. So it's going to rise to the left. Okay, so whatever is happening in between here, okay, whatever is happening in between here, it's going all over the place, but I mean, it's not going to bounce that many times, obviously, but whatever's happening in between here, it's falling to the right and it's rising to the left, okay? And what does this mean? Okay, what this means is that as we are approaching, right, so as we go along the x-axis, right, as we approach infinity, so as x approaches infinity, we are now falling. So our q of x, or our function of x, right, is falling, so it's approaching negative infinity. It's approaching an arbitrarily small number. So as we travel along the x-axis to an arbitrarily large number, our y-axis, our q of x-axis, falls to an arbitrarily low number. And as we look on this side here, as we approach, so as x approaches an arbitrarily small number, right, negative infinity, then our q of x, should I say, our q of x is rising, right? So our q of x is rising, so q of x is approaching a positive, an arbitrarily large number, positive infinity. So that's how we break that down, okay? So we've got to read these carefully. So we're looking for, as x approaches infinity, q of x approaches negative infinity. So something along this line. As x approaches infinity, q of x approaches negative infinity. That's fine. Okay, the second part of it here, as x approaches negative infinity, q of x approaches positive infinity, and that's what matches here. As x approaches negative infinity, q of x approaches positive infinity. Okay, so just watching out for those signs right there. As I said, leading coefficient, if it's positive, it's rising to the right. If it's negative, it's falling to the right. If the degree is even, both ends are the same. If it's odd, the ends are different, and that's all you need to know to be able to answer any of these questions, right? And even to draw a lot of these, and we kind of covered some of it. yesterday when we were looking at the positive and negative intervals of graphs as well. So just keeping that in mind, keeping everything that all our notes in mind here, right? Just all you've got to do is look at the leading coefficient and the degree of the polynomial. So we're really only looking at the leading coefficient term. So watch out for the highest exponent, right? Our highest exponent is 7. That works for us. So this one here is the leading coefficient. So it's a positive leading coefficient, and it has an odd degree, so the ends are different, okay? So that means that to the right, so as x approaches infinity, to the right it's going to, so we have as x approaches infinity, our q of x it's positive, it's rising, so it's going to approach positive infinity also, right? As x approaches negative infinity, then q of x, what does that do? Well, it's going to be different. Q of x is going to approach negative infinity, so it's going to be different from this one. So those are the two that we're looking for, and that's the option right down there at the bottom. As x approaches infinity, q of x approaches infinity, and then the different one as x approaches negative infinity, q of x approaches negative infinity. So what we mean is that both ends are going to be different, and that's all you've got for the end behavior of polynomials. A little bit of practice on it, and I think you will do absolutely fine. If you have any questions, please leave them in the comments below, and I'll be sure to get back to you.